Welcome to the Women Who Code podcast. I'm Jenn Schilling, and today I'm going to give a talk on Data Viz, a primer. And I'm so excited to get to join this podcast. Our overall goal today is to improve and get better at Data Viz by learning some design principles. And I'm so glad that you're here. As I said, I'm Jenn Schilling. My pronouns are she, her, hers. I've been working with data for over a decade, and I absolutely love data visualization. I really enjoy creating charts and graphs to communicate data. I'm the founder of Schilling Data Studio, a data visualization training and consulting company. I'm also the business intelligence manager at Albert, an adjunct faculty member at the College for Creative Studies, where I teach graduate classes on data visualization. And I just love data visualization and design. So I am super excited to be sharing my knowledge with you in this podcast episode. I've also worked as a middle school teacher, an operations research engineer in the supply chain, and a statistician in market research. Over the years, I've learned some key design principles that support me in creating impactful visualizations, and that's what I'm going to share with you during today's episode. I love data visualization and design, so I'm super excited to get to speak to you about these topics today. The first thing we need to think about is, what does good data viz look like? Take a moment to think back to some data visualizations you've seen, or maybe ones you've made. What do you think makes them good? And why does it matter? Why does good data viz matter? These aren't simple questions with straightforward answers. Good data viz presents accurate information in context, it considers the audience, and it presents information in an attractive way while being clear and efficient. It involves creating a meaningful design that enables understanding of the data. Each element of the design should serve a purpose, and distractions should be removed. Our overall goal with good data viz is greater clarity and simplification. When our audience sees a complicated design, they automatically assume that it's going to be challenging to understand, and then they're less likely to engage with it. On the other hand, when they see a clean, simple, beautiful design, they assume it will be easy to understand, and they're more likely to want to engage. When we create data visualizations that make our audience feel ease as they read them, they will more quickly understand the key message, and they're more likely to take the desired action we recommend. When we're intentional with our design choices, the audience notices a difference, and we're more likely to want to engage with something we perceive as well designed. So whether it's the fonts used, the color choices, the type of chart, the titles, the grid lines, or the alignment, these are all design choices that have an impact on how our audience experiences the data viz and whether or not they understand our key message. So why does good data viz matter? It matters because it makes our audience engage with the data, and it helps us more effectively communicate the information. But how do we create good data viz? One of the ways to do this is by using the design principles we're going to talk about today. First, we're going to talk about something called pre-attentive attributes, which are visual encodings that our brains process without our conscious awareness. These help focus the audience's attention. Next, we'll talk about the Gestalt principles of visual perception, which were established by the Gestalt School of Psychology in the early 1900s based on research of how people interact with and create order from visual stimuli. These reduce clutter and the cognitive load for the audience. They also help us understand how the audience will interpret and make meaning from the data viz. Then we'll discuss some basic color principles, because when we use color consistently and according to best practices, it makes it easier for the audience to understand and interpret a visualization. By understanding these three design topics, we can create effective data visualizations that are easy for the audience to understand and engage with. The goal of using these concepts is to reduce the cognitive load of the data viz, which means that the viewer doesn't have to work so hard to understand it. Before we move on to talking about the principles, I want to briefly answer this question. Why am I talking about design in relation to data viz? We don't often think about it, but when we create charts and graphs, we're actually making several design decisions. We decide what data to show, we decide what type of chart to use, we decide whether or not to use color and what colors to use, we decide how to label the axes and what to write in the title. Oftentimes, we let the software we're using make at least some of these decisions by using the default settings, and we might not even realize we're making so many decisions. Or maybe you find it completely exhausting to have so many things to figure out. This is where design comes in. Knowing design principles in relation to data visualization makes creating charts and graphs easier. You have guidelines to fall back on that are proven to help draw attention to the main point you're trying to make with your data. The design principles we'll discuss soon are based on how the human brain processes and organizes information. So by taking advantage of these automatic rapid processing steps in the brain, we can create data visualizations that immediately provide key information and takeaways. These principles also apply in any tool that you use to create data visualizations. You don't have to be able to code or use a specific software to make use of these principles. Design can be used to make good data viz, regardless of whether you use Excel, Looker Studio, R, Python, Tableau, Adobe, or some other tool to create your graphs and charts. Now that I've explained how design relates to data viz and why it's important, it's time to dive into some design principles, starting with the pre-attentive attributes. Pre-attentive attributes can be used to help people understand data, focus the viewer's attention, and create a visual hierarchy. They can also be used to put emphasis on the most important pieces of data by providing visual cues that will automatically draw the viewer's attention. Pre-attentive attributes help us enable our audience to see what we want them to see before they even know that they're seeing it. There are 11 pre-attentive attributes that apply to static data visualizations: length, width, size, shape, orientation, curvature, added marks, enclosure, intensity, hue, and position. For each of these attributes, if you were looking at a visualization, you'd immediately see the element that is different, whether it's a longer than the other elements, it's a different shape, it's oriented differently, it has an extra mark, or it's a different color. Your eye is drawn to it, and you don't have to search for it because our brains are hardwired to quickly pick up differences we see in our environments. Pre-attentive attributes can also be used in text. We're not going to discuss that in much detail, but examples include bold and italics font, color, font size, line spacing, outline, and underline. If you're reading a paragraph and you see a bold word, that's going to stand out to you. That's a pre-attentive attribute. So let's discuss a few pre-attentive attributes in more detail in relation to graphs. One of the pre-attentive attributes is length, which means that an object of a different length stands out. We usually see this in column charts and bar charts, where the part of the chart that is shortest or longest is going to stand out to us. Orientation is another pre-attentive attribute, and this means that an object that's a different orientation stands out. Usually we see this in line charts, or if we're looking at a column and bar chart together. And what this means is that when the slope changes, we notice a difference. Added marks is another pre-attentive attribute. So if we put an extra line on a graph, or say we have a line graph itself and we put some points on top of part of the line, that's going to make part of the line stand out. And so usually this happens in scatter plots when we're using a different symbol for part of the graph, but it can also, as I said, be used in a line graph if we put points on part of the line. And one that we see quite frequently is intensity. So an object with a different intensity or saturation stands out. So that means that an object or part of the graph that has a different color is going to stand out. And also if we're using a scale of colors, an object that's much lighter or much darker is going to stand out. So usually that part we see with the intensity piece and heat maps in shaded tables. So with pre-attentive attributes, they're very useful because whatever is the most different is going to draw our audience's attention. And maybe that is exactly what we want, because we want them to pay attention to the longest bar or the shortest bar, for example, for length. Or maybe we actually want them to pay more attention to all of the bars that are a similar length. And knowing that the pre-attentive attributes exist means that we know that our audience is mostly initially going to focus on the most different element of the graph, whether that's where we want their attention to focus or not. So now we're going to talk about the Gestalt principles. The Gestalt principles of visual perception, as I mentioned earlier, were established by the Gestalt School of Psychology in the early 1900s based on research of how people interact with and create order from visual stimuli. So the psychologists involved with this research theorized that we tend to group elements, look for patterns, and reduce complex images to their simplest forms. And we can use these principles to design data visualizations that will help the audience or the viewer more easily understand them. When we implement these principles in data viz, we can reduce the cognitive load or the amount of processing the viewer must take on to understand the data, because the principles are based on how people naturally interpret and process visual elements. One thing to note about these Gestalt principles and how we view data in general is that we're always looking for structure and relationships. It's important to keep this in mind as we design data visualizations, because our viewers will look for structure and relationships, whether or not they're actually there. And of course, there's interpretation involved when viewing a data viz that extends beyond our immediate perceptions. But it's important to understand the pre-attentive attributes and the Gestalt principles because they influence a person's initial engagement with a data viz. And so we can use these principles to highlight important information, draw attention to certain areas of the visualization, create a hierarchy of visual elements. And using these principles, we can also help reduce the cognitive load for processing a data viz. There are 6 Gestalt principles often seen in data viz: proximity, similarity, enclosure, closure, continuity, and connection. We're going to discuss a few of them in some more detail. And remember, Gestalt principles are all about how we group things together, how we make meaning from a visual stimuli, in this case, a data viz. So with proximity, elements that are close together are thought of as belonging to a group. This can be used in creating a table because we could add more space between rows or more space between columns to help the viewer more easily see the table and connect parts of it together. This principle also applies in scatter plots because we're going to naturally find groups of data that are close together, and those groupings may or may not be meaningful, but our brain is going to interpret them as groups nonetheless. Another Gestalt principle is similarity, and this means that elements that look similar are thought of as belonging to a group. So they could be a similar color, a similar shape, or a similar size. This again could be used with a table design by shading alternate rows to help our audience connect all of the data in that row together. It can also be used in plotting data by making data points of different categories, different colors, or different shapes to help our audience associate all of the points of one category together. Enclosure is another Gestalt principle. And with enclosure, elements that are physically enclosed are thought of as belonging to a group. And enclosure is also a pre-attentive attribute, which means that when we see part of a graph enclosed, whether that's shaded or a box is drawn around it, our attention is going to be immediately drawn to that area of the graph. So enclosure can be used to frame or shade a section of a table or a graph to draw attention to it, or to help the viewer group the enclosed elements together. This is particularly useful when we want to draw a distinction in the data. For example, if a graph displays actual values and forecasted values, we could shade the area of the graph with the forecast to help the viewer separate the actual values from the forecasted values. So now we're going to talk about some principles of using color. Color can be used to draw attention and highlight information and group data points together as it's part of the pre-attentive attributes and Gestalt principles we just talked about. But there's some more specific uses with color in data viz. So when used in a data visualization or dashboard, we want to make sure that color has a clear purpose and it's used consistently and it's accessible. If one color is used to indicate a specific category, we want to use that same color consistently each time that category is included. If one color is used to highlight an important data point, we want to use that for highlighting across visualizations in a dashboard or a report or presentation. This consistency helps the viewer make meaning from the use of color and makes it easier for them to understand the important information. This also means that we don't want to reuse colors on a single dashboard if they aren't representing the same categories. Color should be used with a purpose and not arbitrarily added to a data viz, because using too many colors actually defeats the purpose of associating numbers with colors. Research shows that most people's short-term memory will only retain up to 5 pieces of information at one time, so the more colors you use to represent your data, the harder it becomes to read it quickly. And if you need more than 5 colors in a chart, you might consider using an alternate chart type. The main ways that color is used in data viz is, as we've already mentioned, to highlight a data point or bring the viewer's attention immediately to it. It can also be used to designate different categories or labels, and then it helps the user differentiate between different groups of data. So that first one is more of the pre-attentive attribute. The second one I just mentioned is more using the Gestalt principles. But color can also be applied to quantitative values, either in a sequential or a diverging manner. So sequential color is used to show low to high values on a continuous scale, and diverging color is used to show values above or below a midpoint on a continuous scale. We want to remember that we should only add color when it adds meaning and helps with understanding. And so the main thing to remember about using color in data viz is that color should be used consistently and sparingly. Using color consistently and sparingly helps color keep its meaning and maintains its use as a pre-attentive attribute. If we use too many colors in one data viz, it makes it harder for the audience to interpret rather than easier because they have to work to figure out what all the colors mean. So we want to choose colors strategically to add information or context to the data. And sometimes color's not even needed in a visualization if it won't add meaning. Another thing to keep in mind when using color in data viz is colors meaning. So some colors already have meaning in different cultures, or sometimes they have different meanings in different cultures. So it's important to keep in mind the meaning of certain colors when using color in data viz. For example, when associated with numbers, at least in the US, red generally implies negative and green generally implies positive. So if your data shows an increase, you don't want to use red to highlight the values. If you're going to use any color, you might want to use green, because using green to visualize an increase builds on our audience's pre-existing association of the color green with positive numbers. This makes it easier for our audience to understand the message of the graph. If we were to use red to visualize an increase, that actually increases the audience's cognitive load, or the amount of work they have to do to understand the visualization, because it goes against their pre-existing association of the color red with negative numbers, and it makes it harder for them to understand the graph. Another meaning that we perceive in color is that darker means greater or more. So when highlighting information, it works best to use a darker color for the important piece and a lighter color for the other pieces. This also applies to sequential and diverging color gradients. You always want to use the darkest color for the largest value and the lightest color for the smallest value. And it's important to go either from dark to light or light to dark rather than alternating dark and light shades in a gradient. One other important factor to consider when using color in visualization is color blindness and accessibility. As one example of making sure that your color use is accessible, you should generally avoid using red and green together without providing other visual cues such as down and up arrows or minus and plus signs. If you want to use red and green to highlight negative and positive change, you could also just highlight the negative change with red and leave the positive change in a default font color other than green. And there are several different online checkers that you can run color palettes through, or upload an image of your graph to check that the colors are accessible for different variations of color blindness. And I'm going to share 2 links to different resources in the show notes for this episode for you to use. Another way to test your final visualization for effective use of color is to try looking away or closing your eyes and then looking back at the visualization you've created to see where your eyes are drawn. You could also ask a colleague to look at a visualization and tell you what they notice and where their eyes go first. And that will help you determine if the color used in your visualization is drawing the user's attention to the area you intended, or if it is distracting and focusing their attention elsewhere. So now that you know some about how to apply these different design principles, the pre-attentive attributes, the Gestalt principles, and different ways of using color in data viz, what do you do the next time you're presented with data? Well, I want to talk through now a little bit about my process for how I create data visualizations. So the first step is to think about your audience. Who is your audience for your visualization? What questions do they have? What do they want to know? And what do you want them to know? Your audience is a key component of the data viz process. So think about who's in your audience. What is their familiarity with the data? Are there key metrics they're looking for? And if so, you want to make sure you present those. Once you explore your data, keep an eye out for specific messages you find and ask yourself, is there a specific action you want the audience to take after seeing the data? You'll also want to think about the data literacy of your audience. Are they comfortable looking at data? If not, you'll need to spend some time orienting them to the data first. Their comfort with data might also influence your chart choices. So I always start with thinking about who is this for? Who is the audience? The second step is to explore the data for yourself. So see what types of data are available and what questions you could answer with the data. Your goal here is to understand your data. What's in it? What questions might you want to answer with it? And then you can start experimenting and exploring the data to see what patterns emerge and what messages you find. Based on the questions you want to answer and the type of data you have, you can pick a couple of different chart types to experiment with. And that brings us to the third step, which is to test out different graphs and designs. So here you're going to use the pre-attentive attributes, Gestalt principles, and color best practices that I've talked about so far to draw the audience's attention to the key message. Test out a couple of variations of the same message by using different chart types or applying different principles. And here again, you can ask a friend or colleague to look at 1 or 2 of your visualizations and tell you what they noticed first and what message they got from it. If their takeaways don't match what you intended, then make some tweaks to your design. If you don't have someone else to show your data viz to, you can put a graph or chart aside for a little while and then look back at it and pay attention to where your eyes are drawn first. And is that where you want your audience to look first? And the fourth step is to refine and finalize your visualizations. So you'll take the feedback from your testing and implement it to improve your data viz. You also want to do some final checks based off of the principles and concepts that I shared today to make sure that you don't have any extra elements that aren't adding value to your visualization and message. And then you're ready to present your data viz. Creating data visualizations is an iterative process, and you'll constantly learn new things. When you present data, pay attention to how it's received and the messages your audience takes away. If that doesn't align with what you intended, think about what you can adjust next time. So thanks so much for tuning into this episode of the Women Who Code podcast. I hope you learned something new about creating effective data visualizations. If you'd like my whole data viz design process, check out the link in the show notes, which is shillingdatastudio.com/resources, and look for the data viz design process workbook and training. It's a free guide to get you started and a free training more on my data viz design process. I also have a whole course that dives deeply into the design topics I talked about today and more, called Data Viz Design Essentials. And you can also access that through the resource page on my website. You can find me on Instagram at Schilling Data and on Twitter at DataVizJenn. That's Jen with 2 N's, and Schilling is SCHILLING. Thank you so much to Women Who Code for having me on today's podcast, and I really hope you enjoyed today's episode.